Hello class, today we're going to be learning about electric charge and Coulomb's law. Like gravity, electric charge is found pretty much everywhere. As we've learned in chemistry, atoms are the building blocks of all that we know, from the air we breathe, to the water that we drink, swim, or fish in, to the buildings we live in, to the beaches and amusement parks that we flock to. Yes, even the stars and galaxies are made of these little tiny things called atoms. Okay class, can anyone tell me what's an atom? That's right, the building block of all matter. Can you tell me what makes up an atom? That's right, a neutron, a proton, and an electron. Atoms are comprised of a nucleus of positively charged protons, neutrally charged neutrons, with negatively charged electrons of far less mass, moving about the nucleus in paths known as orbitals. Electric charge is created when there are too many or too few electrons for the number of atoms in a material. This can be seen when you comb your hair, and the hair and the comb each have an equal but opposite electric charge, thereby attracting one another. Or when you reach for a doorknob after walking across a carpeted floor. If you think humidity causes a bad hair day, check out the electrostatic frizz on this little girl. Don't laugh now. Electrostatic force is calculated by the formula F, electrostatic charge, equals K, Coulomb's constant, times Q1 times Q2. The electric charge is divided by the square of the distance between the center of the charge. The magnitude and direction of the electrostatic force completely depends on the charges. Like charges repel one another, unlike charges attract one another. Coulomb's constant K equals 1 over 4 pi epsilon initial, which equals 8.99 times 10 to the 9th newtons times meter squared divided by Coulomb squared. Epsilon equals 8.85 times 10 to the minus 12 newton meters per Coulomb squared. Q equals the electron charge, which equals 1.602 times 10 to the minus 19 coulombs. Now you see how the formula F equals K Q1 Q2 over R2 determines the force between two charged particles. If you double the distance between two like particles, does the force increase or decrease? That's right, decreases. But by how much? That's right, 1/4. Are the particles being attracted or repelled? That's right, repelled. Give two examples of a static charge buildup. Well class, I hope you enjoyed this little video on electric charge and Coulomb's law. It may be the end of the video, but the beginning of your journey. We're going to continue on with electric charge, electric field, strength and direction, and also understand how electric charge direction is going to determine the field strength and direction. We'll continue also in magnetic field strength and direction, but for now, I'd like you to take out those handouts I gave you at the beginning of class. We'll work over some problems and give you a better understanding as to how this system works.